Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Tautomers are structural isomers that interconvert by migration of a proton, H, accompanied by a shift of bonding electrons. Ketoenol tautomerism is the most common type, where an enol, C is equal to CO, interconverts with a keto form, Cc is equal to O, by proton transfer. Moving on to the next step. Identify structure 2. Structure 2 is phenol, hydroxybenzene, which contains an aromatic benzene ring with an OH group. Its molecular formula is C6H6O. Moving on to the next step. Identify possible tautomers. For phenol, enol form, the keto tautomers arise by moving the OH proton to the ring carbon and shifting double bonds, generating cyclohexadienine structures. And for the final step, analyze structure 3. Structure 3 is cyclohexa 2,4-DN1-1. It has the molecular formula C6H6O, has AC is equal to O group at position 1 and to C is equal to C double bonds at positions 2 to 3 and 4 to 5. This is the 2,4 cyclohexadienine tautomer of phenol. Phenol, enol, cyclohexa 2,4-DN1-1 keto is a valid ketoenol tautomeric pair. Analyze structure I. Structure I is cyclohex 2N1-1 to cyclohexene. Its molecular formula is C6H8O. It has 1C is equal to O and 1C is equal to C in a 6-membered ring, with 4 CH2 type carbons contributing more hydrogens. Phenol has the molecular formula C6H6O, while cyclohex 2N1-1 has the formula C6H8O. Since tautomers must have the same molecular formula, structure I, C6H8O, cannot be a tautomer of structure 2, C6H6O. Re-examine the image description. Looking again at structure I, it is drawn as a 6-membered ring with AC is equal to O at top and to C is equal to C double bonds shown, similar to cyclohexa 2,4-DN1-1 but with a different arrangement. Actually, rereading the image, structure I appears to be cyclohexa 2,4-DN1-1 with double bonds at 2, 3 and 4, 5 positions, and structure 3 appears to be cyclohexa 2,4-DN1-1 drawn slightly differently, or structure I is cyclohexa 2,5-DN1-1 and structure 3 is cyclohexa 2,4-DN1-1. Both cyclohexa 2,4-DN1-1 and cyclohexa 2,5-DN1-1 have the molecular formula C6H6O and are both keto tautomers of phenol. Conclusion. Both structure I, cyclohexa 2,5-DN1-1 or another cyclohexadienine isomer C6H6O and structure 3, cyclohexa 2,4-DN1-1 C6H6O are keto tautomers of phenol, structure 2. They both share the molecular formula C6H6O and interconvert with phenol via proton transfer and bond reorganization. Why other options fail? A. I alone, incomplete, because 3 is also a tautomer. B. 3 alone, incomplete, because I is also a tautomer. D. None of these, incorrect, as both I and 3 are tautomers of 2. Therefore, the correct answer is C. Therefore, the correct answer is option C.